Okay, so I want to mention something right here. Yes, this is video 2. I have this right here that bx minus c equals negative pi over 2. I have told you all ahead of time that I am not going to have a shift. So this c right here is my shift. So if I don't have that and it's taken away, that means bx equals pi over 2. So if you have bx equals pi over 2, what this would look like, bx equals negative pi over 2, I would divide by b. Wait a minute. Yeah, I want to divide by b. Just kidding. I was like processing what I was saying. Then x is equal to pi over 2b. Okay? And this one would be bx equals pi over 2. So positive pi over 2. So dividing by b, x would equal pi over 2b. So that means, this is interesting the way these 2's work out. You don't have to remember it this way whatsoever. You're going to know that if that b is affected, it's going to change how we do this. So if you want to say bx equals pi over 2, bx equals or negative pi over 2, and pi over 2, you can do it like that and solve it every time, or you can know this. Okay? All right, so for A tangent B minus C, we're not going to have that. The period's the distance between the two consecutive asymptotes. So your period is 2 pi. Normally it would be 2 pi over B. It's only pi over B because of the whole distance. The period's just pi over B. Yeah, because it's half of it. It's half of the standard, so it's pi over b. Whoa, tangent's evil. Okay, the amplitude is not defined. Why? Because there's no top or bottom to it. A tangent is graphed like this and goes up forever. However, a stretch can happen. And in this stretch, you may find this going on as opposed to a deeper turn like this one. Two different kind of stretches going on here. So let's look at our key points. So the key points actually come back from the unit circle. So I'm going to draw a unit circle over here. And normally our key points are these points. But if you remember, our tangent is undefined. Whoops, tangent equals 0 here. Tangent equals undefined here. Tangent equals the empty set or undefined here. So this, my dear friends, is what's going to make up our key points, okay? Our magic points. Now, what is the period? The period is just going to be, so this is from, would you look at that? Holy mackerel. This is going to be 0. It's not going to be 0. I take it back. It's going to be pi over b. Negative pi over b to pi over b. I got to think about that a minute, guys. Let me think about that. Key points, I know those. Let's fill in key points from this yellow part. So our bottom number will be, what's the lowest it could be? And it's negative pi over 2. I'm sorry, undefined. Oh, there's a problem. 1, 2. These points were important because this is where tangent equals 1, tangent equals negative 1. So we have undefined, or you can write U and D, okay? And undefined, I will take either one. The empty set just means it doesn't happen. I think undefined is probably the nicer word to use. That's the terminology we should be using. So let's do that, not take a shortcut. Undefined. The next 2 points are at -1 and 1. And you're like, wait a minute. If we start on the negative side and come up around this, I want to go in a positive direction. This means that when we're going down the graph, we want to go down the X in a positive direction. I'm going to start here, which is going to be starting back here and going in that direction. So that puts me starting at negative pi over 2 for a standard eraser. This X would be negative pi over 2 to positive pi over 2 to negative pi over 4. Now, halfway between that is 0. That's 0 radians. So this is negative pi over 4, and this is positive pi over 4. So this is sandwiched between. So if this guy is negative pi over 2, and this guy is positive pi over 2, it's easier to see laid out in a line than it is going around this unit circle. This is 0. Well, what's right here and right here? It's pi over 4 and negative pi over 4. So if we read it left to right, that's going to be where you see pi over 2, negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, boom, boom, boom. Okay? Oh, I didn't put a value at 0. Let's go back and fill that in. My apologies. Tangent here is 0. So our terms now are undefined, -1, 0, 1, undefined. Okay? Well, what does the y have to do with anything? What do we do there? This is their a is still going to be in there. A times asterisk plus d. That's what's going to go in this line. Okay? Determine the new asymptotes. Those will be top and bottom. And these will always be the asymptotes. Okay, wait a minute. I don't remember, Ms. Patel, how to find the asymptotes. Okay, the asymptotes are right here. Oh, yay, they're within sight. So number 3, we will put right here. That's plus or minus pi over 2b. Okay, whatever our b is, it's going to be part of it. Graph at least 2 full periods. Oh my gosh, really? Yes. Okay, let's scroll down and try one. Bump, bump, bump. Let's keep it in line so maybe we can see it. So the period is going to be, all right, I got a b. I got a b. So b equals 1/2. So period is pi over 1/2. So our period is what? 2 pi. Okay, so that means we have to go from pi over 2b goes negative pi to pi. Okay, let me show you this. You're like, what the heck? We just got 2 pi. That means it takes 2 pi to complete it. Okay, if all of this is worth 2 pi and dead center is 0, because we are not going to have any shifts. That 0 right here never changes. Just hit me. It's never going anywhere. I'm going to have 0, 0, and this is going to be undefined. Oops, it's very hard to write on this sometimes. Undefined, undefined. All right? Now, I'm going to tell you this period has to be a total of 2 pi. How far away will we have to go negative and positive to make this equal to 2 pi? Because that's what the period is. The period is equal to 2 pi. We have to go negative pi to positive pi. Okay, wait a minute. So what do I do with this cute little equation right here? Well, think about it. Your starting asymptote, if you go pi divided by, and it's plus and minus, 2 times b, which is 1/2. Wait a minute, what's 2 times 1/2? It is 1. It's pi over 1. So the starting asymptote is negative pi. The ending asymptote is positive pi. So this is that plus or minus pi giving you this answer and that answer. So that tells me where I'm starting and ending. So what's halfway between 0 and pi? Negative pi over 2, I hope you said. And what's between 0 and positive pi? Well, positive pi over 2, I hope you said. All right, so now we have everything in here. Just fill in the rest of these magic numbers, -1, +1. And this is just asterisk. There is nothing here that I have to add or subtract. Do you see that? Woo, nothing back there. We don't have to fill this out. It's already done. So now let's go and graph it. Wait a minute, we didn't do our increments. The increments, in case you didn't notice before, the increments, I'll color code this, it's always the distance between any two of these. Well, the distance between negative pi and pi over 2 is pi over 2. If you don't like that one, you could have chosen this one between 0 and positive pi over 2. It's pi over 2, okay? So I have everything in here, and I do know that my starting is at negative pi. That's where the first one is. I'm cheating, not really cheating. I'm looking at these x values. And the next one is at positive pi over 2. And I have a problem. I'm not going to get 2 periods in here. I'll get close. So if I go to graph it, I'm going to be at 0, 0. Out 1. Okay, wait a minute. I need to go pi over 2, which is here, up 1, and negative pi over 2. And wouldn't you know it, down 1, like right in line with this. Hot diggity dog. Okay, if you wanted another one and you wanted to look up other values, you can. But what this tells me is that this is coming along the line here. It's going over to that, going straight to this one, and it's, well, I almost did it perfect. There's a little lump in it. Arrows top and bottom, they go on forever. And you're like, well, we don't have 3 of them. You're right. So the distance between here and here is pi. So here's another pi. So not every pi units. This is a total of, okay, just so you know, this up here is pi on one side, pi on the other. That's 2 pi. So if I wanted another one to happen, I would have to go out here to 3 pi. This is where 0 is happening. And right here at 3 pi over 2, I'm down 1. Right here at pi over 2 past 2, that's at 1. And this would be my other asymptote. So once you've established the pattern, there you go. We have that beautiful piece of work. And this one, we could have just said halfway between is going to be at 1. So it's going to go, and this one's missing the halfway between. It would have been down 1. It was going to here, and then it's going to try to curve. We don't have that other piece. It's somewhere over in here at negative 3 pi. Okay, we got them in. Now, if you want to stop this, please stop it and don't watch another one and see if you can get this one by yourself. I'm going to keep going. So this time I'm going to have negative 3. Ruh-roh, please change your notes. This should not be there. Take it out. I didn't catch it. My apologies. And I've already printed it, so please fix that on your notes. Take it out. Squiggle, squiggle, squiggle. I do not want a C change there. I don't want C in there at all. I'm killing C for tangents because I love you. Okay, so I need to do the period. Okay, so B is 2, so it's going to be pi over 2, and it's already reduced. So the increments, I'll figure out the increments in a minute. That means there's a difference of, this is 0, and this whole thing has to be pi over 2. So halfway on the negative, halfway on the positive, if we split it, we get pi over 4 and pi over 4 away. But this one has to be negative because we go negative to positive. Holy mackerel, halfway between, yes, sorry about this, pi over 8, pi over 8. How do I know that? Because half of a quarter is an eighth, okay? So my increments from 0 to pi over 8 is going to be pi over 8. Increment. I like using this one for the increment, just so you can see where it's coming from. Okay, starting asymptote is going to be negative pi over 4. Ending asymptote is going to be pi over 4. All right, if you want to do what we did above with pi over 2b, it's plus or minus that. My b was 2, so this would be pi plus or minus, sorry, pi over 2 times 2, which is plus or minus pi over 4, which is the answers that I have. See, I cheated and used this other method over here going, I can see what's going on. All right, so where are all my magic numbers? Well, normally they start out undefined, -1, 0, 1, undefined. All right, this time I'm going to have 3 times asterisk plus 1. Well, what in the world is 3 times undefined? It stays undefined. Ladies and gentlemen, undefined times or plus anything is still undefined. So that doesn't change. Now we do -1 times 3, positive 3, plus 1 is 4. Is that really a negative? Holy mackerel. Okay, cool. I love these. I really do. That got moved up 1. This is -3 times 1 is -3, plus 1 is -2. Got all of my magic numbers. Holy Toledo, could we squeeze one more thing into here? This is not very big. All right, so I am now at pi over 2. I need to get a pi over 4. So, and that means I need a pi over 4 over here as well. I'm at a pi over 2 here. And of course it's negative. And a negative pi over 4 there. And the problem is, I'm not there yet. So I'm going to make this in red. This is our tiny little increments that we have to have. And that means I am not going to go past pi on these. I don't even know how far I'm going to get. I'm going to use yellow this time for the undefined asymptotes. They're at negative pi over 4, positive pi over 4, and then if I go, this is a distance of pi over 2, and that means it's 1, 2 black marks away, not the red marks. 1, 2 black marks away. Here's my next one. And 1, 2 black marks away. Wait a minute. How did I end up on pi on one of them and not the other one? Okay, people, that's not good. What did I do wrong? I got 1 in between. I should have 1 mark in between. Did I forget a mark in the midst? I did. Holy Toledo. Okay, I just caught what I did. When I was doing my marks here, I have my pi over 2 here, but I'm missing a black mark here which means I should have red mark for eighths. Wow, sorry. I was like, that's not good. So 1, 2 black marks away. Now we're there. Now we're cooking with gas. Okay, you're like, no, I was never cooking with gas. Okay, and because we have this lovely shift up 1, I am going to put that this is my shift mark. Sorry, we have 1,000 dotted lines. All right, in green, we are going to do our graph. Now, if I look at this, negative pi over 4 is undefined. Those are my undefined marks. What I want is at negative pi over 8, I've got to start at 4. So negative pi over 8 is right here, the first red dot closest to me, 4, all the way up here. The next one, where it was 0, went down to 1. That's where that dotted green, blue line is. Then the next one is down to negative 2. Here's negative 2. Look how skinny this thing is. You want to talk about an ugly graph. It's coming in, riding high here, going over to the dot, going down to here, and following there. Oh, this one's nasty. I am not happy with this one. Okay, the next one is going to be right above the pi over 2. The next dot up here, it's going to come down this line, writing this, and then cut over. Okay, wait a minute. We didn't do our dot below. Dot below is right here. Oh, that's just wretched. I don't even like this one. I'm like, did we have to have the most god-awful, ugly one I've ever seen? The reason this one's so bad is because our numbers are so close. We are way zoomed in. So you may want to use Desmos to double check your work. And then you can see, whoa, didn't mean for that to happen. Arrows top and bottom because they go on forever. Okay, that's just ugly. Just saying, I'm not loving it at all. McDonald's did nothing for me. I am not loving it. All right, so next one. All right, so you see how this is stretched out? And you're like, oh, that's just a negative cosine, or tangent. No, it's not. What happens on these? This is the way cotangent goes because they flip and go the other direction. Okay, so what is the period? The period is no different. It is pi, just like it is in tangent. This is just the reverse. What's the domain? Okay, in this one, x cannot be careful, look at where this is happening. At pi, at 0, at pi, okay? So this one isn't negative pi over 2 to positive pi over 2. It's between pi and 0, okay? So every k pi, not k pi over 2. What's the range? All real numbers, or negative to positive infinity. What's the vertical asymptotes? Where x is equal to k pi, or n pi, whatever letter you would like to use. We're getting rid of the c's, and instead of equal to plus and minus pi over 2, notice the change. Okay, what in the Sam Hill's going on? Let's get our unit circle here, and let's look at cotangent, because cotangent is going to flip. So if tangent was equal to 0, and if tangent was equal to, I got to think, 1 over 0, which was undefined, negative 1 over 0, and 0, this is where they were 1, negative 1, 1, negative 1, at the pi over 4s, okay? So these are all my tangent numbers. If I want to go back and find cotangent, cotangent is undefined here. Why is cotangent undefined? Because it was 0 over 1, okay? Those were 0 over 1. So cotangent flips it, and it becomes undefined. So that means we're undefined here as well. And that means up here we got 0 over 1. So up here, cotangent equals 0. Down here, cotangent equals 0. So if I'm going to go from undefined to 0, I have to use this information here. What is this information here? This is between 0 and pi. That's why this number is 0 and that one's pi. All right? Our numbers change. So we're going to go from 0 to pi. What's halfway between 0 and pi? And those are not our magic numbers. I just lost my marbles. Erase. I put this in the wrong place. So for standard, it's between 0 to pi. Halfway between there is pi over 2. Okay, wait a minute. This looks normal, right? Pi over 4, 3 pi over 4 is where our magic numbers happen. Well, what we're going to have to do here, these are the pi over 4 areas. So it's going up by pi over 4s. And so we're going to start, and it's going to be 0 here. So the value at 0, undefined here. This is undefined. We end on undefined. What happens in the middle is 0. So it looks a lot like what we had before, slightly different. We have a 1 and a -1 instead of -1 and 1. How are you going to keep this straight? You will have to draw the unit circle, and you will have to figure out what your values are for tangent, cotangent. Tangent, cotangent are exactly the same at pi over 4. You just got to remember what area is involved in this, okay? So, increments, period divided by 4. No different. Period, pi over b, the same. Period divided by 4. Or look at either any of these two together. We're not going to have a c, so we can mark those out. We will cancel them. Anytime we see them, we're just going to scratch them out and make them go away. Make the point table and go 2 full periods. All right, so let's see if we can do this. We can get at least one done. This will be our longest video. Okay, I feel green. Let's go green. All right, so I have 2 cotangents, so this is going to be 2 of this. And, b is equal to 1/3. So I have pi over 1/3, which means 3 pi is my period. 3 pi. I can take and do 3 pi over 4 for my increment if I want to. Starting asymptote, I have to do, okay, hold the phone, I don't remember. Let's go back. It's bx, bx over 0. So, starting bx, keep that, bx equals 0. bx equals 0 and ending bx equal pi. Okay, so my b was 1/3. Guys, 1/3, it doesn't matter if I multiply by 3, x is equal to 0. So I'm always starting at 0. Yay, I love starting at 0. Ending asymptote, 1/3 x equal pi. So that gives me 3 pi. Wait a minute. I just figured out I was going to 3 pi. So you can see how it affects here. So halfway between this, 3 pi over 2. I'm going to have to use my brain on this one, and it's getting late. 3 pi over 2. Cut this in half. It's 3 pi over 4. Average these. It's something big. That's 1.5 plus 3 is 4.5. 4 halves. 4.5 is 9 halves. So that's going to be 9/4 pi. 9 pi over 4. That's awful, folks. All right, undefined. Undefined. The middle's going to be at 0. These are going to be at 1, and they're reverse of the others. So it's positive and then negative. The other was negative, then positive. Okay, so that's done. Then we have to multiply by 2. Well, undefined times 2 is still undefined. Undefined times 2 times 2 times 2. All right, so now we're going to graph them. So we have undefined at 0, dot, 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 dot. Undefined at 3 pi. Holy mackerel, here's 3 pi. I need another one. So dot, 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 dot. And negative 3 pi. Dot, 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 dot. Now what we need, I'll go in purple. Let's put all the points that we really like. And 3 pi, holy. Yes, I went to 3 pi. I'm not crazy. Okay, so, oh, I'm trying to do both sides at one time. That's a problem. So halfway between here is right here. This is 3 pi over 2. And then some halfway between point is going to be 3 pi over 4. 3/4 pi. Guys, here's half pi. 3/4 pi is right there. It makes sense that this point, 3/4 pi, is halfway between 0 and this. So this is our 0. No, this was our 0. And our 2, sorry, it would help if I didn't cover my mouth. This goes up to 2. This one over here goes down to 2. Wait a minute, I didn't get my point over here. Halfway over here is right here. It goes down to 2. And this is going to go over and follow, take off to infinity, come this way and down. Over here, I need my halfway point. That's where my 0 is. Halfway between here is here. This one's down at 2. This one's up at 2. I'm trying to line up 2, and it's really hard. Okay, somewhere in here, this is my halfway point between the asymptote and the middle. This is going to come over here and over and turn. And it's taken off really quick. Okay, so there we go. Whoo, doggies. I don't know about y'all, but this is wearing me out. Well, that's not what I wanted to happen. Select. All right, one more. I'm going to tell you right now, take this out. I don't want to do that. Let's do +1. That's the only thing that's going to change on this one is a +1. So if we have cotangent, it goes between 0 and pi. There is no b here, so we're fine. Our period is pi. It's pi over 4. Life is good. Halfway between is pi over 2, pi over 4, and 3 pi over 4. And we're undefined, undefined. There, we can just do undefined all the way across. It's not going to change it. This one is 0 because it's in the middle, but we take asterisk +1, so it's 1. And this is where the value is -1. Nope, +1, -1. Just kidding. I just forgot. And that's at 2, and this one's at 0. All right, so we're going to plug it in. 0 is where the asymptote is, and this goes to pi and 2 pi, and I only have to do 2, and I want to be done, so I'm going to stop at this. All right, so this halfway between, that's pi over 2. This one's 3 pi over 2. And then halfway again is pi over 4. And halfway again. And we need all these halfway points, okay? So I'm going to graph. I feel like doing graph in black. We're going to go up 1. That's where our 0 is. Up 1 is where our 0 is. This is the 0 I'm talking about, that one. All right, and then this one starts higher, so it only goes up 1 to 2 here, down 1 to 0. And so it's kind of like you do this straight diagonal and then turn when you get here, and turn to take that one and go up. This one, up 2, down on 0. Yeah, because they were up 1, down 1. And these units of 1 are really spread out. So down like that. Sorry, that was not a good one. And that one's turning and going like that. This one's not too bad. The next one's not bad either. And I'm going to leave it for you to try, and we'll see how you do on Friday. The kids that get me for 2nd and 4th will get to do this with me, and we will correct it with them as we go. Have a great day, guys. And don't forget to do Delta Math. I got Delta Math on here as well.